Welcome to lesson 3, where we're going to learn about selection structures. Selection structures is a long way of saying if-else statements and teaching a computer to make decisions. I know you've always wished that your computer could make better decisions. Now you have the power to teach it how to do that. For selection structures, we're going to be learning how to control our programs using if statements, if-else statements, nested if-else statements, and Boolean logic. So let's start with the if-else. The if-else is, in Scratch, the C block or the E block, right? Remember these two where you could have a true-false statement and you would put a command block inside of this C, and then this code only runs if the condition is true. Well, the same thing exists in Python. You can have an if statement, the condition comes right after it, so it's the word if, lowercase, then a colon, and then the body of the if statement is going to be code that is on the next line with an indent. You can have multiple lines here if you want to have multiple lines inside of the body here, but they all need to be indented over, right? The indent is basically telling us what's inside of the C. An if-else statement is going to look very similar. You have the word if, your condition, a colon, and then you have this line of code indented over. But then the important thing is that the else has to be back on the same line as the if. This is how the computer, when it reads this code, it knows, okay, this else is not part of the code inside the if statement. It's actually its own structure. And then we have a colon that says, okay, the code after this is only going to run if this statement is false. You have the same structure in AP pseudocode. It just looks slightly different. In AP pseudocode, if is capitalized, your condition is in parentheses, and you have these curly braces that tell you what's inside the body. Same deal with the if-else. So what if things start to get a little more complicated? Let's say you wanted to build a nested if statement, right? Nested if statements allow you to control a program and to use logic that is much more complex. In Scratch, this got really messy, right? Remember, you had if-elses inside of if-elses inside of if-elses inside of if-elses. And this is a program that would read in someone's score and then tell you what grade they got, right? That's what this would look like in Scratch. Well, in Python, we have a keyword that allows us to build these nested if statements without having to increase indentation, which is really nice. So the way you do this is you have your if statement and your condition, and then underneath it, instead of saying else, you use the word elif. Basically, this is shorthand for else if grade is greater than 79, then print you got a B. Else if grade is greater than 69, print you got a C. Else if grade is greater than 64, print you got a D. And then finally, you have to have an else here at the end to indicate that this is over, that this chain, you're no longer including an if statement for this one, right? I mean, you could have just ended with this statement, but by using the word else instead of else if, you indicate that you're not going to put a condition here, and this is going to be the last statement. Okay, in AP pseudocode, again, we don't have this handy elif. Instead, we have to put nested if statements inside of else statements, and it gets really messy. I prefer Python. Maybe you do too. So we also need to have logical operators, right? So we can build more complex conditions, because it's not always just going to be one simple, is x greater than 16? That's not going to be the case with some of our more complicated programs. So in Scratch, you had these diamond-shaped blocks that had an and, the word and you could put multiple conditions inside of here. And, or, and not. These are the three important logical operators you need to build complex Boolean statements or complex conditions. In Python, we have the same thing, but it's just the word and, or, and not in lowercase. And then you would put the operators either on the left and the right side, or with not, you would put it right after the word not. Same thing in AP pseudocode. So what about relational operators? Relational operators are like the comparators. This is how we would compare two values. And remember, in Scratch, they're going to be those diamonds where you have greater than, less than, equal to. Here you see an or statement comparing two things. This is how you would do greater than or equal to, less than or equal to, or a not. In Python, we can do those with compound operators, which we'll look at right here. Most of these operators are going to be the same. You have the caret, the other caret going the other direction. This is an important one. If you're checking if two things are equal in Python, you need to use two equal signs. Okay? That's because the 1 equal sign is the assignment operator, which is different, and it's a common mistake that I've made many times myself, where if you use a single equal sign, that means we're saving the number 0 into the variable x. 2 equal signs means that we're checking if these two are equivalent values. So greater than or equal to, you can combine these two operators like this, less than or equal to, and then this exclamation point in Python, that means not. So it basically is saying here if x is not equal to 0. In AP pseudocode, you also have the same operators, but because it's not a coded language, you have some special characters here that make things a little bit easier. All right, we're going to learn in today's exercises how to use these operators and combine them to create complex Boolean statements and complex if-else programs. But before you do that, there's another thing in Python which makes Python sort of easier to extend. In Scratch, most of the blocks that you need come built in. But in Python, there are lots of different functions that you might want that don't come standard. Instead, you need to include them in something called a module. Okay, so modules are basically like libraries that give you lots of useful methods, lots of useful functions. These are functions that some other programmer wrote these for you, and now you can just use them in your program. It's great. It basically is someone else did the hard work for you, and you can build on their work. The reason you do this is because someday you're going to be a programmer and you're going to write some really awesome functions, and you're going to want to share them with the world. And I hope that you will provide them as a module so that other programmers can build on your work to continue to create awesome programs. All right, so the two modules I want to introduce in this class are math and random. So math is a library that provides lots of useful mathematics functions. In order to use it at the top of your program in Python, you need to write the word import math. Random is a library that basically gives you utilities for creating random numbers. So you would use the word import random. So here you have a list of some of the functions that are available to you in these libraries, but I want to show you what the documentation looks like for these libraries so that you can see how actual programmers share these modules with each other, and so that when you want to explore and find other functions or use other aspects of these modules, that you have the basic understanding and go do that yourself. So let's have a look at what's called the API for these libraries. So this is the documentation for the math module, sometimes called the API, or the Application Programming Interface, which basically gives you the description of how to call the functions that are in this library and tells you what they would do. So you may have noticed that one of the top methods you had was called CEIL, or ceil. This is a function that's going to return the ceiling of x. Basically what that means is it's going to round up. No matter what, it is going to round up to the closest possible integer for this number x. Now we're going to talk a little bit later in this class about passing parameters into functions, but for now, you just need to know that if you see this little x, basically what they're telling you is that when you call math.ceil, you need to put a number in between those parentheses, and that's going to be the number that is operated on. So one of the other methods, if you scroll down, you can find lots of other methods, but one of the other methods that I wanted to look at is the power method. So one thing you can do is if you want to find a method quickly, you type the name of it, then you can do Control F and search for it and type the name, then it makes it a little bit easier to find maybe a method that you're looking for. So here was math.pow. All right, math.pow returns x raised to the power y. This is really useful if you wanted to do exponents in a program. So again, scrolling through this whole library is going to take a long time, and frankly, there's a lot of stuff here that you don't need, at least while you're first getting started programming. But if you want to find a particular method and read about it, go to this page, which is linked in your course, and use Control F and see if you can understand what the description tells you about how to use that particular function. Okay, so I wanted to mention one more thing, which is that you'll notice that these methods say math dot and then the name of the method. This is how you're going to call a method in your program. All right, the name of the library comes first, or the name of the module comes first, so math dot and then the name of the function. And then you need parentheses right after it, and you can pass in the parameters that are needed. Again, we're going to talk about parameters in the lesson where we actually define our own functions. But for now, you've seen these in Scratch. They're basically the little arguments or the numbers that you pass in to this function so that it can perform whatever operation it does. Okay, so this is the format for calling one of these functions. Math.remainder, or the name of the function, and then parentheses. So you're going to see that in your exercises for this lesson when you need to use some of these functions, or using these functions will be useful to write the programs. So let's talk about the exercises for today's lesson. Okay, exercise A is going to be a little practice evaluating Boolean expressions. This is going to be something to build on the skills you developed in Scratch, but we want you to look at some Boolean expressions in Python and see if you can predict whether they would be true or false. Here's an example. Let's say in your code you said x equals 12, y equals 15, and then we had the condition or the Boolean expression x is greater than y. Is this true or false? Okay, 12 greater than 15. Doesn't sound right. That's false. Is y greater than x? Yes, that's true. Okay, so the first one would be false, the second one would be true, and then this one says x is greater than 10. Okay, 12, that's true, and y is less than 20. That's true. Okay, so because both sides are true, there's an and between them, this is going to evaluate to true. All right, so you're going to have a lot more of these, and it's going to be a chance for you to practice these skills, practice reading Boolean expressions, and figuring out whether they evaluate to true or false. All right, and then in exercise B, you're going to write 3 mini programs. Okay, this is going to be a chance for you to really get some practice writing Python code. The first exercise is called divisible. This is going to be an interactive program where a person gets to input one number and then a second number and then checks if one number is divisible by another. Okay, so there are a couple ways you can do this mathematically. Checking divisibility, you can look for what the remainder is, you can look for whether you get a float back. All right, there are multiple different ways to do this, but I leave it up to you to find the solution. Next, you have geometry. Geometry is going to ask you to generate a random number in a range. Okay, so you're going to need to look up in the random module. You're going to look up the method for generating a random number in a range, and then calculate the volume of a sphere based on this number. All right, if you've forgotten the formula for the volume of a sphere, shame on you. Just kidding. I didn't expect you to remember that unless this is not a geometry class, but you can look it up. You have the internet at your fingertips, and you should look up the formula for calculating the volume of a sphere and then output that number. All right, and then the third exercise is you're creating a short true-false quiz. Okay, where a person gets to take this quiz and you can then check if they got the answers correct and then output their score at the end. Okay, so 3 fun little programs for you to practice working with the methods, to practice writing if statements, to practice using Booleans and building Boolean expressions. All right, good luck, have fun.